There we go. Sorry, y'all. I was still muted. Okay. Hi. So dynamic programming. Dynamic programming is one of the harder parts of prepping for the data structures and algorithms interviews. It's not immediately intuitive like working with arrays and strings might be. However, I've tried to put together some patterns that will give you more confidence in approaching them. I primarily program in Python, so all of my examples are in Python. However, you will see throughout all of this that I will be using the word arrays instead of lists, just so that I can make it accessible for everyone. Alrighty, so overview. Oh, real quick, if you want to follow along, this link is also in the chat, so you can click on it and look at this at any point. If you want to contribute to it, feel free. This is all on the Women Who Code GitHub account. All right, dynamic programming. So the two, so I'm going to go over 3 different types. Today we'll actually walk through the pathways pattern. I have a little information about dynamic programming in Python. I've simplified it. It can get way more intense in that discussion. But basically, because recursion is not a great thing to use in LeetCode doesn't seem to like it. And sometimes locally it doesn't work as well. All of my solutions will be going from the more of the, the memoization route. And another word for memoization is basically caching. So what is the first main thing you need to know about dynamic programming? Dynamic programming is all about caching your value or values, whatever they may be. What is caching? It's basically avoid doing the same work repeatedly to avoid spending unnecessary running time or resources. I have a link right there to WTF is memoization, and I highly, highly recommend reading it. Leo does a really good job talking about the differences between caching, how memoization is just very similar, and how it's used in dynamic programming. Now, this is a very, very, I'm trying to break down dynamic programming problems into 3 different types. And so that's what you'll see here. My type 1 is basically you have a value and it's constantly updated. You just have one value and that's what you look at. Type 2, you use an array. Type 3 is even more intense. You basically have arrays within arrays and you just keep updating those things. So dynamic programming has 2 main characteristics. The first, you have a cached value. The second is there's some kind of math involved. You have to figure out the equation. So each problem is going to have like a basic structure, which I'll go over, and then you're going to get to the part that's unique to it. What is the math problem we're trying to solve? And as we go through examples, we can work out how to think about that. It's a really hard skill, the hardest part of dynamic programming. And I done so many dynamic programming problems recently, and I have not yet found like a quirk to make it work better, faster, or to understand it more easily. You really do just have to work through things a lot. Don't be afraid to take out a piece of paper and draw it out. If you're in an interview, be like, hey, I'm gonna bust out a piece of a pad of paper and pen, and that is okay. For these kind of equations, you kind of really need to be able to visualize it. All right, type 1 examples. Okay, so to remind you again, this is when you have a specific value and you keep updating it again and again. I'll let you guys read this on your own. The basic gist is this is a pattern that I've used the last 2 sessions with my groups when we were doing dynamic programming. A lot of dynamic programming uses arrays. You can also use like linked lists and other things, but for the majority of questions that I have seen, they are generally some type of array. And so because of that, I start with let's access the length of the array because we're most likely going to use it at some point. Then we need to understand that there's going to be a value that we need to save. So that's our caching value. There might be an intermediate value, and then we're going to loop. Within the loop, we'll often find that there's like a max or minimum used. And usually you'll have to reset things. And then you will get to the mathematical equation And that is, again, the hardest part. But if you follow this outline, it will help you get started so that you can at least go to the basics. So the last few weeks, I've done max subarray, which is listed here, and I've done the house robber problem, which is also listed here. So if you want to review that on your own time, feel free. Since I've done that the last 2 times, I'm going to go over something different today. I also gave one type 2 example. I did not have time to list out the pattern for type 2 example, so I will go back to that at some point. And then here's an example of how to do it if you are basically updating an array. Again, you can check that on your own time. Here's type 3 examples. This is where we are going to stay for the most part of today. You're basically going to create a matrix, and you're going to learn how to populate it. Now, there is a pattern for this matrix. Oftentimes, when you are working with the matrix, this is what you're going to have to know. And again, this is the most difficult problem. So if you're new to this, please start at the first type, which is just updating a value, a sole singular value. Then make your way to arrays. And once you have arrays down, go to the matrix, which basically is arrays within arrays. Alrighty, so a few things you need to know when you are looking at the different dynamic programming matrix problems. You need to know your columns and you need to know your rows. If they don't give you a grid, you need to create one. And then you're gonna fill in. Usually the pattern will go, you'll fill in row 0, column 0, and then you'll fill in the first column, and then you'll fill in the first row, and then you're going to start filling in from the grid. And grid 1, 1 is where you kind of start, like the values start doing something, and you really see the beauty of dynamic programming. And then at the end of a matrix, you generally return the value stored in the rightmost bottommost corner, depending how you implement it. But generally I try to do it so that I'm always getting the last thing. That is my answer. So today we're going to go over the unique paths problem. This is something using dynamic programming. If we have time, let's see, which screen can you guys see right now? Can you see LeetCode? The Postgres one. Cool. Alrighty. Thank you. All right. Just making sure I put my help on the side just so I can have it while I'm walking through this. Cool. Alrighty. Let's reset. Alrighty. So we're going to reset. And I'm going to walk through this using the pattern. And if we Elaine, let me know how I'm doing on time. If we have enough time, I could go into unique paths too. So I call the matrix, the first type of way to go through the matrix, I call it a pathways problem. You're basically trying to figure out a path. And so that's why one of the main problems that teaches you it in especially LeetCode is the unique paths problem. So let's look at this. We have a robot. He is located at the top left corner, and we somehow have to get all the way to the bottom. How many possible unique paths are there? Now, let me get the filler. Yes.
This problem has a way to cheat.
Okay.
I mean, this is you know, height plus width, choose. You know, like you have here, you know, the width of the grid, you know, the height of the grid. So, you know that the robot needs to make, I guess, 7 + 3 steps, but you know that 3 of them are down. So you just can choose 3.
So I'll just jump in and remind everyone, we'll save questions for the end or type them in the chat. That is a really good point. I think I read that factorials are actually hard to calculate. So you do need some sort of like way to trim the tree so that you're not like doing factorials of factorials over factorials. But anyways.
Okay, yeah.
Questions for the end. Okay.
Cool. So I would like to say it again, and I wrote this in my pattern section in the document, that what I am proposing is not the necessarily best way to approach all these problems. It's rather a way to give people who are beginning a way to think about dynamic programming and to feel less scared when approaching it. Once you understand the basics, you can definitely optimize there are some other ways to solve this. For example, I'm trying to use a dynamic programming way that basically maps the value, that shows the pattern. So it's really, really important in programming to understand pattern. Pattern recognition is huge. And so I try to use patterns in all the 3 different ways here to really engage it and put it in your mind. Dynamic programming, I can do this. This is just a pattern, a pattern, a pattern. And then once I get the pattern down, I can then explore and go further on. So just so you know, that's the approach I'm taking here with that entire document. I agree that there are probably some better ways, but this is just, I think, the easiest way to get going, get started, and then you can iterate on it. All right, so unique paths. So the first thing we're going to do is we're going to look at how many columns and how many rows. Can you guys see me on line 3? Yeah, cool.
Yeah.
Alrighty. So we want to figure out, okay, do we have a grid? Do we have a grid yet, anyone? Did they give us a grid?
No.
Awesome. Okay, so because they didn't give us a grid, we're going to have to make our grid. So let's make our grid. Now we have a pretty basic thing here that we can copy and use, and it will work. So our columns are M, our rows are N, and then this will produce, let's see what our, okay, so this is going to, and just so you can see what it produces, print grid. So let's run the code. And so now you can see we've built a matrix of that. One moment, there we go. Okay, cool. All right, so let's undo that. All right, and now the next thing, we need to start filling out the grids. So how many ways are there to get to the first points? So we are here at grid 0, 0. How many possible ways are there to get there? I guess anyone? 1, yeah, awesome. And then for the first column, we are going to basically, so this is how it goes. You basically use a range, which is really lovely. So something we can easily do for a range is how many rows do we have?
3.
3, awesome. So let's put that in there. And our rows here is what? Our rows are M or N?
Rows are M.
Okay, and then we're going to have to figure out math. So we'll get back to there. Now we're going to go to doing the columns. And columns were which one?
M.
Awesome. All right, and then we're gonna go and we're gonna have to fill out the math. So we're really lucky for this one, and this doesn't really require a lot of math. Basically, there's only one way to get across in, hold on, I think I need to be able to show you guys. Let me see. Let me bring up something so that I can draw for you. That would probably be easier. So let me bring that up. One second. All right, so just so you guys can visualize it more, I'll be able to go back and forth between this now. Oh, it's taking a while to load. Okay, maybe I'll come back to that. This way. Ooh, Zoom is heavy. It's a heavy application. All right, we're gonna go back here. So to figure out how to get here, the basic gist is we're gonna just do ones. We're gonna just do ones across. Why are we doing ones across? Right now, we're not trying to fill out anything special. We know that there's only one way to get to the first square. And so we know that there are going to be at least one way to get to the rest of the squares in the row. And for the second, for the column, we know that there are going to be at least one way to get to the column. Is that obvious based on there's at least one way to get to the starting square? Does that make sense why we're using one to fill out the first row and the first column? It's okay? Okay. So now,
I'm confused about why you said at least rather than exactly.
we're gonna iterate through and then I'm gonna show you how you can tell. Does that make sense?
Okay.
Okay. Okay, so we're gonna do the next part now. We're going to start using the number that's above and left to fill out things. Now this one, we get really, really lucky. And it's basically, we're going to have the number. Now this one is really easy because you're basically looking at the box of the number on the box above and the number on the box below to figure out how many what should my number be? So if I am going to this one right here, do you see the little squares? This square would be 0, 1, I believe.
Yes.
Right? Okay, awesome. So then with 0, 1, we're gonna be like, okay, there's nothing above it, so that's 0. And the one to the left of it is 1, so it is going to be 1. So this is to the left. And then just to make that a little easier, we'll do to the left. And then we also tried looking at what was above, right? Above. And so how would we describe what is above? What would that look like? How could we get access to what was above?
I minus 1 and j.
So the first one, yeah, perfect. I minus 1 and j. Oops. And how about to the left?
Left. J minus 1, I.
Say it again.
It'll be I
And j minus 1.
minus 1.
Awesome. Cool. All right, so now we know how to get above and how to get to the left. And now I need to add these two together to figure out what it actually is. So I want you to be able to see all of the grid. So I'm gonna print it out right here. So when we return, you'll see it. Okay, do I have any other prints? Okay, so let's see. Oh, I made the return too far out. There we go. Nope, still outside function.
Above. If you go all the way up,
Uh-huh.
you have a print on line 9.
Good eye, and then where is my function level?
Might need to indent one more.
Thank you. Rows, did I not do it? Oh, duh, forgot to update it. Oh, sometimes we forget to update things, right? Okay, so where is my... Alrighty. Where did it have rows again, guys? Help me find it. Where is rows? What line is that?
The very bottom.
Oh, yay, thank you. Probably could have made that a lot easier if I just renamed N and M at the top, right? So you can change these. You could do like column and rows, whatever you want up there. Alrighty, okay, cool. So we can see it. And now if we were to, let's loop through grid so you can see how it works. So maybe I can print it. Can I print it like that? Oh, you know what? Let me see if this is open yet. Alrighty, so let's go here. So insert text box. Oh, that's very small. Let's make you bigger. Alrighty, so as you can see, we looped through here. We had 1, and then we looped through to 2, and then we looped through to 3. Now, why, hold on, this may not make sense based off this. So I minus 1 and j. I'm gonna take this over here. So that's, you can also see it here. Okay. Okay. So remember, we are starting at 1, 1. So we are at, where are we right now? We're at, that's that one. Okay, so let's iterate through. So this one is 0, 0, right? We've already set that. This one is 1, we set that earlier. Hold on, something is not working here. That worked, but why isn't that?
Should have 1s across the top, right?
Yeah, what did I do wrong here? The answer is 3, but it should have 1s across the top. But yeah, it should look like this. Yeah, huh. Why did that feel wrong? Let's see, what did I feel?
So
actually, right
you're
there.
using Python, right?
Mm-hmm.
So are you able to, when you do above and to the left, do you have something that handles when you're out of range? Because Python often, like if you have a list, if you put in a negative number, it just takes from the back end.
Yes, that shouldn't be a problem for this one because we're
right, because you already set the range to start from 1, right?
Mm-hmm. Yeah.
But I'm just trying to figure out why.
Mm-hmm. Let me submit it, and then it will fail, and then that passes. That was not what I intended it to do. Alrighty, let's look at that again. Alrighty. So let's see here. Above and to the left should have been like that. Okay. So what happened here? Alrighty. Above and left to fill out. Above and left. So then above is this one. I minus 1. I is 1. 0. And then j would be 1. J1. That would be 1. Oh, that's why. Do you see it? Do you see it?
Isn't the grid 3 rows and 7 like what's the value of the row and the columns of the grid?
The grid?
Yeah, for the current test case, how many rows and how many columns are there?
There are 3, where are we? There are 3 columns and 2 rows.
Okay, thank you.
Okay, guys, I am having trouble explaining this. Do you want me to focus on this and explain to you or move on to the next one? What would you prefer? I know that I want to be mindful of time.
No, I think we should understand what happened.
Okay.
You've got 15 minutes.
All right, let's do that. Okay. Let's go here, and then we're going to basically loop through this, and I'm going to show you it. Just make that a little smaller.
One thing that I would check is the order of the dimensions. As the way that the two-dimensional array is initialized. N is the first index. So I would just check that.
Okay.
If you look at your code, you
Mhm.
can see.
Oh, you think I switched them on here?
That grid equals, you
Yeah.
can see that times N. So N becomes the first index because you're doing M length arrays and N of them, but N is the outer outer list.
Okay, so I probably need to do this one then. Where is it? Another way to do this could be
என்ன எதுக்கு ஜூஸ் கேக்குற எதுக்கு நட்ஸ் வேணுமா
Oh, you can just switch the M and N. Just give it a shot.
Wait, so is n the number of columns?
And that would be, yes, we're switching index out of range. Yeah, I think that would not. Let me try.
And
Yes.
when they say m by n, does it mean, do they give the rows first or the columns first?
Let's see. This here.
Actually, it doesn't matter. They're numerically.
Mm-hmm. Should still be able to get there. I'm not
I
sure
mean, it
why.
would still come up with an answer. I'm just wondering for other types of problems.
Is the rows and n is the columns. Just when you look at the example of the input, m equals 7, and in the picture there's 7 columns.
Thank you.
And hold on, I typed in something wrong somewhere when I was changing things. Let me go through and try to figure out where it is. There's the grid there. And
It's the grid.
no, it does need that. Yeah, I forgot to put that back. Because then I would need to change everything downward. Okay, why is that working that way? Let's print, all right. Print statements it is, everyone. We're all, all right, this is, all right. Let's see, print grid. So, 0. Grid. Let's see. And then let's do
Your parentheses on line 17.
good eye. Thank you. Grid. This is grid. Righty, and then we have final. Alrighty, so let's see. That one, okay, it does both of them. Huh. Where is that one being set? Okay, so 0, 0 here. Oh. Okay. And then first column. Okay. First row. It's setting it, hold on, let's see. So this should just, this one here. Do you guys see line 12?
So on line 8, are you making a grid that's entirely zeros?
Yes.
Okay.
See.
Is it a pointer issue?
I'm trying to see that. Did I put it? Like,
That was an excellent question. It is a pointer issue.
okay.
You also don't need the line where you set the corner element to 0.
Okay.
Oh, no, you need that.
Oh, above it, right?
Yeah, I'm
So
not
we'll
sure
already fill it.
because it
If-
will set the first row and the first column all to
Mhm.
once, so you're not going to need that.
You sometimes need this in the pattern. That's why I was just trying to show
Yeah.
it there.
But
So just
this problem,
note
I
that.
don't think you need it.
Yeah.
So in line 8, initialize your column, the inner. You could do like, you have to basically do a new array for each row because it's pointing to the
Yeah. I probably needed to do like range, right?
For I in range, like you could do a list comprehension. This is how I usually do it. So like 0 for I in range in its own. Yeah, exactly. So that it would run that for each n.
Maybe use this in another one.
Oh my gosh.
Oh, bad.
I hate this.
Oh, I hate list comprehensions.
I just
Okay.
pointer issue. It's so annoying.
Yeah. Hold on. Let me do it. I forgot how to do it. Does anybody remember?
Not so Juliana has it in the chat.
Let me look at the chat.
I'll put it together.
There is chat. Cool. Thank you. Let me go. Thank you.
It's just add a 0 before and then a for statement later.
Thank you guys. All right. This should, let's see. All right. That gives us what we expect. Awesome. Yep. Pointer issue. Thank you, everyone. I'm going to update that in the code. Wonder why I still passed. All righty. Hey, everyone. Interesting. Okay, that's that one. Obviously, I have to update that because it's a pointer issue. I will do that after this. We have how many more minutes, Elaine?
5.
5. All right, questions? Sorry about that.
What do you mean when you say it was a pointer issue?
So the way that the grid is created can differ. Let me see if I can show you my terminal. I'm going to open it and let me share a new screen. Share screen. Okay. You guys can see my terminal now?
Yep.
Cool. Alrighty. So depending on how we initialize something, so let's try pointer issue. This is the original way that I tried to initialize it. So what was it, like 2 and 3? Okay. Something. Oh, yes, I did. There we go. So, okay, so let's look at this. Okay, so it's initialized like this. And so when it's initialized like this, let's update it. Pointer, choose 0, 0 equals A. And now let's see what it looks like. You see now how, because of the way I created it, that they were the same row. So now anytime I update something and I just mean to do this, it's automatically going to update it for the second row.
Yeah.
Okay. And now I'll show you the difference. This would be no pointer, no issue. Do right way, how about that? So we had an S3 and 2. Okay, and so let's see what it looks like. So right now it still looks the same, right? But when you try to initialize it here, and let's do the same thing, we'll just call it A. It will only do the one that we actually wanted. Does that make sense?
Yeah, that makes a lot of sense. Thank you so much.
Yeah, and I'm sorry I left that in my code. That's really, really bad. I don't know how it passed.
It's just really helpful to watch you debug it though, so I really
Yeah.
appreciate taking the time to explain this.
Yeah, of course. Other questions?
Do you know what topic is this in Python, like especially this pointer issue? What topic covers that?
So this is probably list comprehension and making matrices.
Okay.
So just practice building your matrices.
Mhm.
And I actually had this issue. Apparently I'm having issues with pointers. Ended up figuring out. But when I was trying to create a matrix within a class for, I was doing an interview and they were testing me on Minesweeper. And I had to make Minesweeper, but each cell had to be its own object. I had this issue and then I figured it out. So apparently it's been a cause for me. So it does come up. So I'd highly recommend looking at how to properly instantiate a matrix, which again is an array of arrays. If not, you might have like the pointer issue like you saw right here.
So is it
Doesn't
only
just come up.
Python?
In this case, it makes all the first element in the column as A if you don't declare it as.
It's because I'm basically recreating this twice. Do you see how I'm like, all right, do 3 zeros and then make them the same thing twice? Do you see that?
Yeah.
And then in the other area, I'm saying, okay, I want 3 zeros, but they're going to be different rows. By me just changing the syntax here from ×2 on the outside to for I or whatever in range 2, I'm saying give me 2 distinct rows that are separate from each other.
So it's better to initialize them as list comprehension rather than doing that, right?
The best way is to do it like this. I apparently forgot or was lazy or I don't remember when I did it. And the right way is the one that's on there as right way.
So I would recommend reading up on, as a topic, pass by value and pass by reference. This isn't specific to Python and it's not specific to multidimensional arrays or matrices. This comes up as a bug in a lot of situations. Pass by value and pass by reference, you should pull that. And then if you want to dig into Python specifically around it, Python has a great doc page in the standard docs called the Python data model, which goes into specifically how object references are handled.
Okay, thank you.
Yeah. Do you have a link to that resource?
I put one for passing by reference by value there. And then what was the Python one, Jen?
So not right now, no.
The Python data model.
Okay.
It goes into everything in terms of like, how does class work and all of it. Like all of the guts of Python are on that page. It's a very intimidating page if you don't have a pretty strong formal grounding. So I would look at things bit by bit and really look at, not go directly to that page, but look at some of the principles behind it first.
Also, I'm glad we got to debug together, guys. Next time I will be more prepared. Later tonight, I will, oh, yeah, don't use it as a trap. See exactly what I did. Thanks, Julia.
No problem. I just saw that. I thought it was funny that that's what the title of the thing was.
Yeah. I will update the code by tomorrow. So just please note that when you see me creating lists that way, that I will update it by tomorrow so that you all have the right things. And if you see anything else wrong in my code, please let me know. Again, these all pass LeetCode, but if you think something's incorrect, hey, we're here to help each other grow and learn. You can help me out.
That was awesome. Sorry, this is Elaine. I wanted to jump in and say that, like, you know, these bugs will keep hounding you because even as you like get better, you know, you'll just, it's like so easy to rely on patterns. And anyways, what I want to say is that if you're in an interview situation, and because I have like done this error many times and still continue to do it, you can always fall back, like, and I'm like, oh, I know how to do this on list comprehension, but you can always fall back on doing a normal for loop, and because that's what a list comprehension is anyway. So don't be afraid to simplify, and even like practice doing problems in a language you're learning so that you remember how to do things like the good old fashioned way, because that there will always be for loops, while loops. Like just rely on your normal constructions. That would be my advice, because I have had brain freezes and brain farts many, and I wish I could go back to those interviews and say, Elaine, stop trying to be fancy, just use a for loop.
And what about the time complexity of this?
Let me go back to it to look at it. Let's see. So here we are. The time complexity is, so we're only really going through the loop at most once, two. Oh, this is, yeah, this is a little bit less than n squared. So it's not great time complexity.
We can't see your code, but so you're creating the grid, but then you're doing each cell you're calculating once, so it should be just m by n, right?
Yeah, it is n by m. I forgot that it was two different ones down here.
Sorry, I meant m plus n. And no, sorry, m by n.
Yeah, times. No, sorry, I misspoke. It is O n times m. So sometimes in big O, you can have other things. Like sometimes they'll give you n, sometimes they'll give you like a k, and sometimes that will be, it's not, this one is a more uncommon one. You'll usually see things that are like O n, or they'll try to get you there, or like you'll see some O1 things. And Elaine has good input as well.
For space complexity, do they, it's just the extra space you create, right? So like if they pass you an object, you don't count that object.
If you're reusing the same object. So in the next one that I was going to go over, in unique paths 2, you actually reuse the object they gave you. So that space complexity is even better because you're just putting it in. This one, because you have to create it, that is your complexity. And so the space complexity here would, I guess, be the same as the time complexity. So that, again, that would be, I'll put it together. Time complexity. O n times m, space complexity. Again, because we are creating the grid. When they pass us the grid and we're reusing it, much better, right?
There's a way to reduce the space complexity, but is there a way to reduce the time complexity? Is the question.
Probably. Let me see. Let me look.
It's not clear to me how to reduce the space complexity, at least not by much, because you have to have, like for every cell that you compute, you still need to have the values of the cells above and to the left stored somewhere. So like you could set it up somehow so that only those values stick around, but I don't think it's easy.
So there's a very more difficult implementation using, it's not an easy one. So there is another approach to this that basically gets you to one space complexity, and then very, very complicated time complexity. It's like writing log a billion times. I don't generally, or maybe I'm just not that senior. I'm senior, but apparently I'm not that senior to be able to go through that. I've noticed just in general when I'm working that it's generally good enough to be like O of n, or sometimes O of n squared is sometimes okay. But if you're doing like the Facebook, Google interviews, yeah, you're gonna have to know those really, really, really intense observations. So I'm going to, I don't know how to say this, I'm going to paste it to you. This is the optimal time complexity. Note, oh wait, hold on, let me look at yours too. That's the optimal that, and then the space complexity is easy. So if you were to go like super hardcore, honestly, if someone's gonna test me on that hardcore one and want me to do that one, I'm like, I don't know if I want to work for you, because I don't know if you're judging me on the right things. That's personally my thing, but yeah, you can get it to whatever that is. Sue, let me see what you're doing.
Can you paste to that solution? I'm so curious. I want to read it.
Yeah, let me paste it.
I'm like, what kind of Google Code Jam bullshit is this?
It's like using like a Python, like it only works for Python.
This is exactly what I was talking about earlier. It's just calculating. It's just calculating n plus n, choose n.
And then the problem becomes how to do binomial coefficients, which is, yeah, that's like that can be built into like a math package.
But yeah, this is what I meant by cheating. You
by cheating, yeah,
import
right.
something, you know.
But then they would ask you in the coding interview, all right, well, implement factorial, and then you would do it recursively, and then he would be hosed.
Yeah.
I hope they would say, or they would say either implement factorial or figure out the time complexity of this with an optimal factorial algorithm. This might use something fancy like Stirling's approximation, which I like looked at, and I'm just like, nope, that's like real number theory. But yeah, it's built into like math packages because it is the fastest way to compute factorial.
So good.
Learning.
So yeah, what did we learn from this? DP is good. Like, it's still way better than brute force, which is exponential, and it's way better than trying to compute factorial, because you could get cute and do it, or they could actually ask you to do the math theory behind it, which we could learn another time. I am confident that we can learn it. It's just not useful right now.
Well, it's also not that it's very useful for, you know, most work in tech to know this particular like math. Does that make sense? Like, I mean, you know, knowing a ton of number theory is not really required for most tech jobs. So it just doesn't seem like a good use of time.
I'd expect the data scientist I interviewed to know that.
Oh, I would expect it for data scientists, yeah.
Okay.
I think it's important for at least to know the limitations. Like, I'm glad that I'm at the point where I can be like, aha, if I just wrote this based on factorial, like that wouldn't work from a practical standpoint. Does that mean I'm going to go and learn Stirling's approximation today? Probably not. And I'm still struggling with, like, in my career, what do I want to get really good at and what do I not? Because you can't be good at everything, and there's practical aspects to consider. But I'm trying to be more appreciative of the fact that higher math is important, and I'm just like trying to figure out how much of that iceberg I want to surface for myself.
I mean, I guess what I mean is, in the grand scheme of things, if your objective is to learn dynamic programming, this doesn't seem like the place to start. The place to start seems to be more like, you know, the traditional stuff. Like, okay, I need to control the order of operations, and then I need to control the size of the cache and stuff like that.
I think this is a great example of it, though, because if you, like, the only way you're going to get to a reasonable solution that we can all understand is through dynamic programming.
Yeah.
because otherwise you're doing brute force, which we can all enumerate the paths in our head and realize that that's not a good way to do it. Or
Right.
you're relying on your counting method, which is like basically like waving a magic wand and saying like import SciPy and hope for the best. And so the way that we get a handle on like the space of the problem and the way that we collect all of like the possibilities, you know, cut down the true possibilities and save intermediate values in a table is through this technique. So yeah, I think it's a good I mean, this is a great problem. I've had it before for homework. Thankfully not in an interview. Although now that I have, maybe I'll remember. I'll be a little further along and I'll create my matrix appropriately. This is also a great way to like enforce to like practice your data structures. I know a lot of people like when I post like, hey, who wants to like learn about arrays or linked lists? People are like, boo-hoo, thumbs down, let's do the hard stuff. But I'm like, no, we need to review that stuff too, because otherwise you get caught up in these weird pointer issues that you need to keep practicing.
And I'm interviewing right now, and almost everything I'm being tested on, FYI, besides like the Facebooks and Googles, are arrays, string manipulation, hash map stuff, just FYI.
So what does part 2 look like?
Part two is great because we actually, they give us a grid. Part 3 is even better because then we try to find like, we're using words. I'll update. So if you're gonna read the code, just know that I need to fix the pointer issue, but everything else should be legible within the document. And for the part with words, I actually draw out the matrix for you.
Cool, thank you.
Thanks, Krys. Do we all want to code now? We've got like 45 minutes left.
Can we check unique paths 2 as well instead of coding?
Oh, Krys, I'll send you an update to the robber problem.
Awesome, sounds good.
I do want to, so we have mentors tonight who came to help you guys code. So let's save part 2 for another night. Krys, would you? I'm sure we can work out a time to come back. I also want to be mindful of the recording length. So yeah, let's do part 2 sometime soon. And I'm gonna stop recording now and then we'll break into small groups and do some problem solving. Thank you so much, Krys. This is Krys Flores. For people watching in the future, hello from, yeah, thanks for watching.